Our friends, my dear students, in 12th Physics second volume, last class radioactivity, we have seen the emission of alpha particle. What are the methodology that we are adapted to expose or to express the alpha decay? Today we are going to say about beta decay. What is beta decay? Here, when any excited state nucleus which will emit the electron, then this is called beta minus. If suppose it is emitted positron, then it is called beta plus. That means both are beta particle. It may called as beta minus or beta plus or called as beta particle. Here beta minus, it is nothing but an electron. Here beta plus, it is nothing but positron. Here electron. This is called positron. Both are equal in mass as well as the same charge but opposite to each other. This is negatively charged, this is positively charged. The amount of charge both are equal, and mass of the particles are also same. That's why these particles are emitted means either beta minus or beta plus happens to be a decay of beta. Now we have to give a suitable example. Now I have given a suitable example for beta decay. When you say X is a parent atom Z, that is called A. Then Z is the atomic number and A is atomic mass number. And whenever it will emit the beta minus. Here first we have to consider beta minus. Emission of beta minus, it is nothing but electron emission. Then there is no change in the mass, but the atomic number is adding one number. That is, parental atom is considered to be Z, then the daughter atom is called Z plus 1. There is no change in the atomic mass number. With here minus 1 is 0. This is called electron with anti-neutrino. Neutrino, or this may called as nu is called neutrino. Neutrino is nothing but like nu. You may call as nu. Or anti-neutrino is anti-particle. Anti-neutrino is nothing but nu bar. Anti-neutrino. So this is the example for beta emission, that is beta minus emission or electron emission. Here the parallel atom mass would remaining the same, but atomic number is added 1. If you are adding these two, minus 1 and plus 1 both are equal, then the parallel should be equal. Why these two particles are emitted? That's the thing that we have to analyze. Here, when you consider nucleus, there may be a proton and a neutron here. When the neutron inside the nucleus are splitted into two more particles, like when you consider neutron are bifurcated as a proton plus electron. electron plus antineutrino. This is a very good example how we are obtaining this electron as well as antineutrino. Here we have to consider one important concept. If suppose the neutron is inside the nucleus, then the decay is possible and it may be split into two particles, proton and neutron along with the antineutrino. In case if you are consider the neutron in the outside the nucleus or anywhere else in separately, then there is no decay. Then the decay is also possible. Decay is also possible. Either separately it may be available or within the nucleus, then it may split it into proton, neutron and antineutrino. This is the fundamental phenomena that we have to clear to understand this concept. That's a very, very important concept. This is the process. Now, the second concept. Second concept is nothing but beta plus emission. Beta plus, it is nothing but positron, E plus. This is called positron emission. For example, if you want to give an example for this, you can consider carbon isotope of 6C12 or 6C14. You have to consider isotope of carbon, that is called excited state. It may be adding up number 1, that is called 7. 7 means nitrogen. When you say 1, hydrogen. When you say 2, helium. When you say 3, lithium. Likewise, when you say atomic number, then we can, as per the periodic table in chemistry, you already studied. When you say the atomic number, immediately you can say the element name. Likewise, when you say 6, it is carbon. When you say 7, it is nitrogen. There is no change in the mass. But whereas here, along with the nitrogen, there may be a particle which are emitted here are called neutrino. This is called antineutrino. Here, this is called neutrino, which was ejected. This is the fundamental example for this beta minus decay. Are you clear? Okay. Now, we are going to say about beta plus decay. When you consider parental atom Z and A, then it will become Y and Z minus 1. Z minus 1, there is no change in the mass. Plus 1, 0. Here electron, here positron. Antiparticle of the electron is said to be positron, or antiparticle of the positron is said to be electron. Both are same. Charge and mass are same but opposite each other. Along with the neutrino. This is a fundamental equations to explain the beta plus decay. This is a fundamental equation to explain the beta minus decay. Suppose if you have considered sodium 1122, then it loses one atomic mass number, become 10. That is called neon. 22 plus E10 first term plus neutrino. This is very good example for beta plus decay. This is a very important concept to analyze to understand the beta emission. Here we already told whether neutron inside the nucleus or anywhere else, it may be split into two more. But here in this concept, how can we obtain this positron and the neutrino? Then proton may produced or splitted into neutron splitted into neutron plus plus as well as neutrino. Here, this is the fundamental phenomena how we obtain these particles here. Here we have to consider one important point. If the proton is outside the nucleus or separately you have to consider the proton, it could not be able to decay the process or split it into furthermore particles. There is no split when isolated proton. That's a very important condition. When it is available in the nucleus itself, it may split into neutron plus E plus and plus neutrino. That's a very important concept. And another important concept, nucleus emitting neutrino as well as antineutrino not accumulated in the nucleus itself, but only by means of splitting neutron and proton, then these particles are emitted. During the splitation of neutron, there may be antineutrino are produced. When the splitting of proton, then neutrino are neutrino are produced. Here, in general, there is no place for neutrino and antineutrino inside the nucleus. Only because of the splitation of this neutron as well as proton, this was happened. This is a very, very important concept to analyze the beta decay. Then, next topic, neutrino. How neutrino was produced and how can it may be invented or discovered by Fermi as well as suggested by the Pauli in 1936, and it was discovered experimentally in 1956. That's a very important concept you have to clear here. If you consider beta decay, beta minus decay, then Z A and Z plus 1 Y A plus 1 electron. Now, here in this process, the outcoming electron kinetic energy may not equal the kinetic energy of an electron by another process. That's why the scientists are confused why the energy of the kinetic energy of the electron are different. First question. The second question, if it was happened, then the energy, conservation of energy are affected and the conservation of momentum also affected. So that along with this particle, there may be some other particle may be compensate this energy as well as the momentum. It may be third particle which will be available along this process. That's why Pauli suggested in 1936 there may be a third particle which occurs within this process, and that may be called, we don't know the name of this particle, but it should be lesser mass, and it should be emitted along with this process, and then it may not suggested by the or invented by the experimentally, so that it may called as neutrino. That is called neutrino. It was called as neutrino. This is the process that was suggested by Pauli, who is a famous scientist. Again, it was proved by 1956. 1956, I think. 1931, 25 years after, 25 years after suggested by Pauli 1931, after 25 years, Fermi, who invented the neutrino particle experimentally proved and find the neutrino particle. That is the process. Here, neutrino is nothing but a particle, yeah, zero masses and zero charges, but almost equal to zero, but not absolutely equal to zero. Not absolutely equal to zero. It has lesser mass, lesser mass, but no charge. No charge. This is Fermi suggested that neutrino, regarding neutrino, and he gave another important properties also. It has four properties. One is, it is the first point, neutrino is nothing but it has zero charges, zero charge, no charge. That is no charge. Second one, it has an antiparticle. It has an antiparticle. Antiparticle means nu is the particle, then antiparticle is said to be antineutrino. Neutrino, antineutrino. Both are same but opposite to each other. Both are same but opposite to each other. And third property, these recent experiments and old experiment as per Pauli as well as for me suggested that these neutrino have lesser mass. Lesser mass. That's a very important concept. Lesser mass, not equal to zero, but lesser mass. And fourth important point, whenever hit this neutrino of any matter, then it will not interact with each other. Neutrino which will not interact with matter, so that nothing will happen. That's why this fourth property is very important, because sun produces trillions of neutrino per second. That's why it straight away to the earth, and we are affected by means of this neutrino, and trillion number of trillion neutrino which are affected our body without any interaction, and unknowingly it will enter to our body. These are the four important properties for neutrino. This is a very important concept to understand the concept of neutrino. This is called beta decay. Beta decay is nothing but beta plus and beta minus. Both are emitted. Neutron are splitted into proton plus electron plus antineutrino inside the nucleus or somewhere else in the outside. It may be splitted. But whereas if you consider proton, then there may be only splitted may happen only if it is available in the nucleus itself. If you consider the separate proton somewhere else, then it will not decay. It will not split it into some other particle. Is not possible. That's why decay is not available for separate proton. That's a very important concept. And neutrino, this is the property of neutrino. This is a very important 3rd mark and 5 mark question. I hope you understand clearly. Thank you, my friends.